So this is the experiment on simple machines. That's the pulley, and we rigged it up here. And people who have done this experiment in physics know that it's actually rather difficult because it falls apart occasionally, frequently. So you may really want to use two people. So what I have here is you have to take overall, you have to take 3 measurements by using 3 pulleys. We do the one in the middle. Notice how many strings are supporting what we have down here. There's 1, 2, 3, 4 strings supporting that. If you rig it up a little bit different, you might have an odd number of strings supporting it. But in my case, I have 4 strings supporting it, and then the 5th one here is where I'm going to have the counterweight in a moment, respectively the force probe. I put this bottle on here, which is 500 milliliters, 500 grams, plus the plastic. I come up with 516 grams is what I measured. Okay, well, 516 grams on here and 4 strings pulling this up or holding it up. I would expect that I need a quarter of the force or the mass in order to hold it up. So 516 divided by 4 is 130 grams that I have here. And again, I have a plastic bottle of 16 grams at this point, if you could hold here. Here we go. So now we're de-securing it. And I'm going to pour, I measured this before as well. It just so happens that we did it before and it worked just right as we did it. And then I measured the mass of water that I poured in here, which is 118 grams. That's why we know that. So I have a total of 134 grams pulling on it as the counterweight. Okay, there we go. So here, the weight that it's holding up here is, the mass that it's holding up is 516 grams, which is around at 5 newtons. What I have on the other side is 134 grams, which is 1.3 newtons. Remember that the conversion is relatively simple. Just shift the decimal point from grams to newtons. So this is what you would have to record. The mass that it's holding up is 5, the weight that it's holding up is 5 newtons. The counter force here is 1.3 newtons. And as I said, we have 4 strings. Now in the lab report, it says something about a token distance of 1 meter. That means that we lift this up here by 1 meter. And then we put it on the pulley, and then we're gonna pull it up with the pulley 1 meter. Well, that would mean I would have to pull on the string here with this amount of force on here. And notice that this is balanced at all times. I call it a token distance because you really don't have to do it. You have 4 strings supporting it, which means you have to pull 4 meters of string in order to get there. So you really don't have to do that part. You just know it. So you record that, well, you have to pull 4 meters of string, even though you don't have to do it. So those are the numbers you would have to record. The 5 newtons here, in this case, the measurement here is 1.3 newtons with 4 strings, which means you pull 4 meters.